A large class of video generation models are what are known as motion transfer models. These models take an input video, known as a driving sequence, of an object moving in some way. Through appropriate training, they learn this motion and are able to transfer it to a new image of a target object that the model has never seen before. So they generate a new animated video of the target object moving in a similar way to the object in the input video. An example of such a model is MonkeyNet, developed by Ciarin et al. It performs motion transfer by extracting moving key points from the input video. So this animation over here is the input video that was fed into the model and it was trained on it. After the training was done, it was presented with new images that were stationary, and the model was then able to transfer the same motion in the input image to these new objects. This here is another example of MonkeyNet at work. Over here is perhaps a more impressive example showing how MonkeyNet can work on human features. So again, to reiterate, this animation here is the input video, and these images at the top were presented to the model, and what the model generated was these videos in the bottom. This is also another example of MonkeyNet at work. Now we move on to another example. This example is called Everybody Dance Now, developed by Carolyn Chan et al. It works, the concept of this model is similar to MonkeyNet. It consists of a pose detector that extracts the pose from the original video, and then it's able to transfer that pose into new objects. Now, let's take a look at what you can do. So this over here is the input video that the model was trained on. This here are the target objects, and you can see them just awkwardly doing bad dance move. But here's the impressive part. Using the model, we are able to transfer the dancing in the original video to the new target objects, and we can see that they're dancing in much the same way as target video. This is the same model with a different input video, and you can see that it does it quite well, but there are a few artifacts to consider that might improve with more training data. Finally, another model that does motion transfer is known as few-shot adversarial learning. Now, this is a very new and experimental model, and in fact, it does not even have a viable implementation, like a publicly available viable implementation, but it's currently in the works and it should be available soon. Now, here's what this model does differently from the other ones. Many video generation models that create talking heads of some person have to be trained on huge data sets of the images of that person, so that's able to create new talking heads like this. This model, developed by Zakharov et al., addresses that issue and allows one to create talking heads with as little as 8 images with quite impressive performance. So let's take a look. So this over here is the input video, similar as in the other models. These over here are the training frames. These were also passed to the model, and it then learns to transfer this motion to that new images. So it does so by extracting the landmarks, as you can see here, and then it's able to copy those landmarks into a new image. Over here, we see living portraits. So we have this portrait of Marilyn Monroe, and it's able to, and using that same driving sequence, it's able to transfer the motion and create a talking head of Marilyn Monroe. This is another example. Finally, Albert Einstein.